Hello, good morning. A meeting is about to start. So if you haven't already signed into Zoom, please do so. It's going to start in 2-3 minutes. See you there. Hey, good morning to everyone. Uh, can you hear me okay? Is my video okay? Could you please type in the chat box? Audio, video clear, AVC. I'm waiting for a chat. Can you hear me okay? Hello, can you hear me okay? Hello?
The host has disabled group chats.
Oh yeah, just 1 sec, sorry. Okay, can you try now, please? Can you type? Just give me 1 moment. I'm still checking.
Chat box is disabled. Please enable the chat box now.
Yeah, okay, 1 sec. Sorry. I thought I did. Just 1 sec. Can you try now? Oh, It should be enabled
Now,
now.
still problem. Not enable the chat box.
Okay, got it. Got it.
Yeah, enable.
Yeah, okay, thank you. Sorry about that. I officially welcome you all. I will read out all your names. Good morning, Abhishek. Good morning, Anil. Sorry, my screen. Yeah, good morning, Roshni. Good morning, Krishna. Good morning, Sharesh, Lalit, Sandeep, Abhishek, Muthu, Jatin, Harshavardhan, Parag, Rupa, Hari, Anil, Mugilan, Venkata. Thank you, guys, for showing up very early. You are the early birders. Just to pay respect for the victims that we lost, all our brothers and sisters in the earlier plane crash. Could I humbly ask you to pause 1 minute silent, please, so we can pay our respect to their lost souls? So just 1 minute silence, and I will start. Okay, thank you so much for turning up early today. So let's start the session. This is going to be a webinar chat, so only if I see some message on the chat box, then I can move on, because not to interrupt everyone, I muted everyone. So if you can type some messages, then I can follow the chat and I can respond. Yes, Prakash, it's been a while. It's nice to see you back again. So hopefully you will get something out of this today as well. Okay. So most of you would be all aware by now. The topic I'm going to disclose to you is about how you can set yourselves your career pathways, earning 8 lakhs and above. Even as a fresher, you can do it. The potential is out there in the market. So is it okay to know the reason for your presence here? Is it because of June month you're here, or are you here to find a job, or are you here to upskill, or are you moving to electronics engineering? You are from different department, or some of you may be from here, could be an entrepreneur or freelancer. So if you could type in the chat box any of those, JUNE, that's why I put June. Thank you, Prakash. Upskill, yeah, fresher. Yeah, I'm just waiting for the chat. Roshni, yes, job. That's great. Rupa, thank you. Sandeep, job. That's great. Vishwa, to find a job. That's great. I would like everyone to be involved, please. So could you please type in any of those words? Hari, upskill, thank you. Pradeep, looking for a job. Shreya, looking for a job. Shreyas, Vishant, thank you. Banu, Shreyas, Nagendra, good. So most of you guys are typing. That's really good response. So you're all here for a reason. First of all, I thank you so much for your Sunday morning to dedicate, and you could have done anything out there, but you thought that this would be useful for you. So thank you so much for tuning in, and I'm sure I won't make you waste it for the next couple of hours. So, okay. So I can see from the chat, yes, Roshni is looking for an internship. Yes, we'll talk about that later. I got a lot to cover, but it's really good. Yes, keep the chat going. So now and again, I'll pause the screen and I'll move. I got two monitors, so the chat is in the next monitor. So that's why I will move from left to right. So I beg your pardon if I don't see through here most of the time. Yeah. Okay. Sorry. Can you see me okay? Is my video and audio okay? Yep. Thank you, Vishwa. Thank you. A lot of guys saying yes. And please feel free to chat with me in the chat box, and I will pause and watch it every now and again, and I will answer. And if you have any questions during the webinar, there will be a Q&A session in the end, and I'm trying to find a chat box where you can put all your questions in there. Or if you have any questions, please note it down. I will dedicate right at the last and I'll answer all your questions. So don't worry, because not to stop the flow, I will go in a flow. And if you have any questions, please keep it to yourselves and put it in the chat box and I'll answer right at the end. Okay. So most of you all here today to find a job. And believe you me, I was like you 25 years ago when I did my engineering. And since then, I moved upon doing different things, which you will know about me shortly. So first of all, I will start with the flow. So I got two flows to show to you. So the career pathways, and there is another flow called embedded system design bank. Sorry, I need to clear the screen. Just 1 sec. Okay. So I'll first start with the career pathways. So most of you all here to find a job. So this would be a good way to start. So these are all the four major departments, if you like, or major areas where it is all high paid jobs, starting with software, hardware, and in project management and in administration. So if you are in the second year, third year, or final year in the ECE or Triple E, can you type in the chat box if you are studying, if you are learning, which year you are, or if you have completed your studies? Could you type in the chat box, please, which year and which department? Yes. This camera got a bit of a issue, so it keeps moving back. So it has got its own mind. Um, VLSI final year, third year, Varshita, great, graduated ECE, very good. ECE, final year, 8th semester, very good. Graduated 2025, well done. Third year, Hari, well done. Final year, completed BE8, sorry, Prasad, graduated. Nivya graduated, VLSI, third year. Mayank, great. Final year, Ashwita. Sorry, I'm just moving between frames, so I'm just reading. Good. Um, I'm s- I'm happy that you chose to come and attend this webinar. I'm sure this would be really worthwhile because I did a lot of market research analysis and all the studies. So what I'm presenting to you would be really useful for you. So I will start with the career pathways. I'll go along. I'll start from software because most of you have typed you are already graduated in the last couple of years or you are just graduated. So most of you might not aware a lot of things that I'm saying. If you want to know more things, then I strongly advise you to take a pen and paper and note it down, because the minute you write it down in a piece of paper or in your notebook, it will be helpful when you go and revise. So that's why I humbly ask you to take plenty of notes. That will really help you. Okay, I'll start with the software. So what is in the industry, software engineers are called as DevOps engineer. So this is the frame, or this is the question, or this is the word you will be circulated around if you're in the industry. They are called DevOps engineer, which is also called a developer. I'm based in Blue Mountains in New South Wales, Australia. So here we call DevOps or developers. And when you talk about software, these 6 jobs are really like a hot cake. There is plenty of wanting in the industry. Like if you want to get into software engineering alone, then there are plenty of jobs which I will show to you. So it starts with the DevOps engineer. DevOps engineer do all the development role. Whatever you learn so far, most of you, I saw that you are learning or finished VLSI. Yes, VLSI got the DevOps engineers as well. Some of you have typed ECE. Yes, there are a lot of potential in the DevOps engineer as well. And part of the DevOps engineer, some people would like to move into real software, that is into JavaScript and VB, Oracle, that sort of thing. So they will be all classified into software developers. And from there, there are different job roles starting as a software engineer, software architect, embedded software engineer, and firmware engineer. So these are all some of the jobs that's listed with software out there. Excuse me. I'll move into hardware, which is where this is mostly oriented the webinar, because most of us, we are all VLSI based, ECE, Triple E, and electronics and instrumentation. I saw a couple of people typed in as electronics and instrumentation. So this is all for us. So in the industry, we are all called as design engineers or designers. In short, they will call, hey, designee, come. I would like to have a chat with you. That's how the interpretation here in Australia in the industry looks like. So I just classified designer into just the basic 10, or if not the best 10 job profiles out there, which you can also write down these names. And when you go and look for the job, you can type in any of these keyword names and you can get plenty of options, which I will show you shortly. So in the industry, I'm not sure how they would classify in India, but in Australia, in UK, US, Canada, outside India, these are all the job titles which we call here our engineers. So start with the electronics design engineers. So what they do is they do most of the front end development in hardware, meaning they will design all the boards, the PCB circuits, what goes inside the circuit, like what will be there in the power circuit, what will be there in the communication circuit. So they are the engine of any project. So these electronics design engineers will get really high pay because they get the product started and they implement from start to end. And then there is hardware engineer. The hardware engineers are mainly focused on designing the layout sort of thing. So from the electronics design engineer, the hardware design engineer will take their brain and their skills and they'll go and develop skills from the electronics design engineer. And there will be, particularly in major companies, a dedicated group of people who do nothing but PCB design only. So there will be, I worked in a lot of companies, there will be 5, 10 of us only do PCB design. And for the PCB design, once we make that, then for safety purpose, there will be a technical mechanical engineering or CAD design engineering people. They will be doing the enclosure design, which will be enclosed on the top of the PCB. And then there is the embedded systems engineer. Systems engineer do the overall engineering. They combine the software engineers and the hardware engineers, and they check for systems. So which application that particular system is designed for. So they check on the top view, if you like. And then there are also other names, which is also similar to electronics engineers, electrical engineers. And the recent one is mechatronics engineers, combination of mechanical, electronics, and electrical. And there are industrial designers, which is all moved into robotics, and then embedded design engineer. So by going through any of this, you can start from anywhere and you can move in the ladder, and eventually you will be ending up in a high paid job. So these are all the highly available jobs available out there, not only in India, it's also available outside India as well, because most of you are in India. My strong advice is try to find somewhere in India, get your experience first. And there are plenty of opportunity for freshers as well. So don't think that I'm just graduated. How am I able to find any work or any job? So that's why I'm here. I'm going to tell you everything, how you can do it. So stay focused until the end. You will be getting everything what you come for. Okay, so that's the hardware side of it. So the next one, after you have gone through software and hardware, you can classify what's called as a project management. Most of you for a freshers, when you, even though you get into electronics design engineer or a hardware engineer, your first role could be a project engineer or an associate engineer. This is what I analyzed in India. They employ you and they put you into an associate engineer or a project engineer. That means in the first few months, like 3 months or 6 months, what the associate engineer and project engineer will do is they do market research analysis for that particular application or for that particular design to be developed. So those two classify under associate and project engineers. And then eventually they will move into a junior project engineer where it's like a bridging role that will send you to an electronics design engineer or a PCB design engineer or whatever you name it. So the top three are the freshers where you can target and you can get in. And by knowing three skills, which I'm going to reveal to you shortly, by knowing all those three skills, you can simply bypass the top three and you will definitely end up into an electronics design engineer straight away. So people who can't get into electronics design engineering job straight away, they can start from here, from associate engineer, project engineer, junior project engineer. So I have a personal experience. I came back in India in 2014. I attended interviews just to see how the market was in India. So I had a couple of offers from Intel and Samsung. Even though I worked here for many years, in India they considered me as a starter. So they offered me to put as a associate engineer and project engineer, and that's how I come to know what they actually do. So although they all engineers, but they meant to do a lot of document work. Like you need to study, you need to do your research. That's how in industry you got to start. Before starting any design, before designing anything, you need to know what you are going to do. So these two engineers are the pillars for that major project that's going to happen. So they collect all the data, all the evidences, all the market research, all the tools that's available in the market. And they will go and talk to the higher engineers in the company, and they form a good relationship, and they'll say, sir or ma'am, I have gone through and I done this research. If we do all this for our project, then we can definitely do this design really well. So that's where the connectivity comes. And then eventually, if you want to stay in that part of lane, you can move into a project manager and program manager down the line. So I just want to give you an overview. And for some other people, like if you're really wanting to get into administration, so these are all 5 hard jobs available there. So most of you would be wanting to be a database or website administrator, mostly interested in website design, or office administration, system administrator, you name it. This is all for you to get your foot into the industry. So doesn't matter if you want to start your career in software or hardware. Believe you me, one of my first job is I was as a system administrator. So that was my first job. And because I put a lot of effort and hard work in it, and after 3 months, immediately I moved from system administrator to a design engineer because I know stuff, I learned it. So they know after you're in the team, they'll move to a different role. So don't get yourself down. Oh, I'm going to only start as a system administrator. No, 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 not like that. It's for you. want to get into the industry. So for you to get into the zone. So that's why these different roles are available. So if you are clear with this career pathways, could you type I'm clear dash CP so I can move into the main embedded system design? So this is just a general flow. Yeah. Oh, hello, Badu. Thank you. Thank you. Yeah, Surya, thank you. Uh, Somebody said that they couldn't see the mind map screen. Were you able to see this mind map? Kodishwara, yes, good morning. By the way, if you are using your mobile phone, you need to slide left or right to see my presentation screen, because mobile phone will only show the chat screen first. So you need to, depends upon whatever mobile you are using, you need to slide left or right. Yeah, yeah. Okay, a lot of people saying clear, clear, clear. That's good. So I'll jump into the most wanting career that you all been waiting for. So this is our embedded system design skills bank. Can you see the screen? If you can see the screen, can you type ESD in the chat box, please? ESD. I'm waiting for a chat. Thank you, Vishwa. Thank you, Jaychandran. Thank you. Thank you, Nagendra. Thank you. Thank you, Vera. Thank you. Thank you. Thank you, guys. Thank you. So most of us, including myself and you all, we all belong to embedded system design industry. So that is really one of the top standard industry, because we move things, we create things, we design things, we design for a lot of people usage. So what you design, what you're going to design tomorrow would be able to be used worldwide, and it will be used by millions of users. So be proud of yourselves, whoever you are in the embedded system design or in that matter VLSI. So we are in the design field, it's still emerging. So um, thank you so much for choosing this path to be an embedded system design engineer. So I'll start off with the technical hard skills, what you got to develop. By the way, I got 25 years experience by now, but you won't get everything if you're graduated. So eventually, by end of, say, 10 years, you will come down the embedded life cycle, meaning the whole loop. So don't worry if you just start with one skill and develop yourself into achieving the full circle. Then you will be knowing the whole industry, the whole implementation of applications and design, etc. Okay, so what do we have in technical hard skills? Just one sec, I will maximize this. Can you see the screen now? This is much better, I guess. Yeah, thank you, Rupa, thank you. Okay, so there are some of the analysis that I made, what would be useful for you. So I listed there in the technical hard skills. There are a few other minor things, but you can start with something from here, and then you can work your way up, and then, yeah, sky is your limit. So, okay, what are all the fundamentals you need to start with? So as you can see, the fundamentals, every program in the embedded system design is based on C-based program. So that's why I'm talking about all these fundamentals. You got to start with one, C program. And nowadays, people are writing code in Python. So this is in embedded software, not in software. IT software is different to our embedded software. First of all, please understand that. So we write code to talk to registers. They write code to talk to applications. So totally two different things. So don't get confused. So start with embedded C or C and move to embedded C and Python. And there is JavaScript. We will be using very minimal of it. Being an embedded system engineer, you don't have to learn full JavaScript, just the few codes, and MATLAB and C++. So these five are the five basic fundamentals. You can start with one programming or C++, try to get everything from that, and then you can simply move on to learning other languages. And most of you, yeah, sorry, Siddharth. Sorry, Rust and C are same. They're almost identical, but the syntaxes will vary. So, but in for major applications, we all start in the industry with C program and move to embedded C because that gives a very good prototype for a lot of things for technical spec checks and all of that. So C is still widely used in every project. So that's why I put C on the top. Rust and C almost identical, but they are not same. Yeah, this is to answer Siddharth. Okay, so once you are organized and once you know all the fundamentals, then you can move into the embedded style of it. So when you talk about embedded, there is plenty out there. So you can start with embedded C, which I will talk to you during the webinar session. Embedded C, when I started learning about embedded C or C programming for that matter, I learned to code with opcode, mnemonics, and operands in a small piece of box, and only you put 0F00, F0001, so opcode and mnemonics and operands. So that was 8051 microcontroller board or MCP board, and then that moved to 8951. Still, there are few projects in the industry which is based on 89C51, but mainly these days, all the major complex projects are all ARM based, like ARM Cortex M4, ARM7, PIC, AVR, ESP32 for all communication sort of microcontrollers, which are widely used. And this all collectively called embedded system design and IoT. So start with one of the microcontroller and be master at it. So you got to know everything. Its architecture, its IOs, its peripherals, its communication style, what its application, where it can be used. So if you're thorough in one microcontroller, the principle and the logic, everything almost the same. Like if you have two timers in one microcontroller, there may be three timers or four timers, but the logic will remain the same. The number of peripherals may increase, but everything you study from one microcontroller and you can learn eventually. So that one microcontroller study will get you to the job. So once you are in the job, you can start to learn about other microcontrollers because you're already familiar and you're already more advanced because you know everything. So it would be easy to learn. So don't start learning two or three microcontrollers for a start because that will make you really confused. Because in one microcontroller, it will say, oh, I am only 32-bit wide data. And in the other one, it would say 16-bit data wide. So there will be a lot of conflicts and confusions happening. So for that matter, start with one microcontroller, finish that, and then study the next one. So that's how you can start learning yourselves. Sorry, I'm just stopping to see what's the chat going. Santosh is asking which microcontroller is best, sir, but it depends actually on the application. So most of the time ARM and depends on the communication, whatever way you are doing depends on the application. The ARM and ESP32 are widely used in the industry now. There are plenty of big projects going on and the AVR at Mega, but ARM and ESP2, the STM32, these microcontrollers are more versatile and they are readily available in the market and you can use it for any project. So yeah, that's for Santosh. Siddharth is asking, can you suggest a good resource for embedded C? Yeah, sure. If you stay till the end, I was about to reveal you a bonus book, which was given to me from my mentor. So I will give you a free ebook, which basically explains everything from embedded system design point of view, which is the front runners. Um, at the start of the session, I said the electronic design engineers design what should go into the design, meaning all the components, all the software, what microcontroller they need to use, what environment it has to be programmed, and all of that. So I got a book similar to that, so you can also use that. Shipana, yes, I will come to that Verilog. So I'm about to talk to you about Verilog, which I will. So yeah, I got your questions. I'll answer to you shortly. So this is about the embedded system design and IoT. So if any IoT project, that will be mainly based on ESP32 or node MCU, we call it, because we are connecting between node to transmit and receive. So that's what another word for node MCU. And then from here, you can start to develop your own driver development. So mostly in the industry right now, say you got your job, so you got there, and the first 2-3 months, what they will ask you to do is do research analysis. So you need to gather all the required documents, the data sheets, the reference manuals, whatever technical documents out there available. It's your responsibility. You need to talk to your senior peers or talk to your fellow colleagues in different companies or whatever, and you need to collect all those documents and start to study. And your job, because why they give you to freshers, because you are fresh out of the university degree, because you guys can learn a lot and you guys can summarize a lot, which gives the senior engineers a lot of input straight away. They will take your role. Oh, so and so have done their job. So from here I can pick, oh, okay, he's suggesting ARM microcontroller. Okay, he's suggesting a Verilog, or she is suggesting a VSTL programming. So like that. So the first 2-3 months, you put all your hard work into your requirement gathering or document gathering. That will really, really help you. And then once you are familiar with that, then you will be moving into designing your own driver development. When I say driver development, this is for all the communication protocols, which I will cover maybe later on if there is time. If not, then some other session, which is your serial communication, your I2C, your SPI, your USB, your LIN, whatever bus you want to do. So those have a dedicated driver development, which you need to develop on the side of it so you can communicate through it. And there are a lot of free real-time operating systems out there, which also can be linked with the embedded systems. And Raspberry Pi, if you are into more image processing, like signal audio and signal video processing, Raspberry Pi is really good. And my expertise mainly, my master's. Sorry, I got to mute. Sorry, excuse. Sorry about that. Okay. So my expertise lies in VLSI, which I did back in 2003, 2005. And I worked in both ASIC and FPGA. So most of you have said ALSI and VLSI, sorry, ASIC and VLSI. And I can see SIPNA, Verilog too. Yes. Verilog is a very good advantage when you want to start developing your skills with Verilog, because the front end in ASIC is all about Verilog programming. In embedded, we concentrate to target directly to write on a register program in the form of bitwise operations. In Verilog, you go and write module by module. So, in Verilog, this will work like this. So a black box, for example, I got a chip here. So this is 2 microcontrollers. So these microcontrollers will be given to you in Verilog programming. You know what is connected to all the what the input output devices are. So you will be directly writing to that input output device rather than targeting into the internal registers in Verilog. And these days there is system Verilog too. So depends upon the application, you can also get into that sort of area and role. In ASIC itself, there is a backend. So in the backend, there are plenty of opportunities also available. So one of the biggest one in Bangalore is Intel Mentor Graphics. They both do all the memory adaptation units, and Qualcomm, There are other Broadcom as well. So they are all into more communication oriented, which what we classify as backend because they design the actual chip itself. So for example, we have seen the old micro SD cards, the memory card. So internally inside that memory card, there will be millions of transistors. And that is all designed by an ASIC backend engineer, which is called a layout engineer in the design arena. But some of us, we can't really get into a VLSI job directly straight away. But if you get into embedded first, and if you have done 1 or 2 projects with embedded, then moving into VLSI is much easier because that's how the employer think that you already have the industrial exposure, so they move into any VLSI projects. And then when you talk about VLSI, there is another big area called FPGA, Field Programmable Gate Array. This is similar to ASIC design, but this can be remodified in the field. After you make certain product, you can go and talk with your client and you can change your modifications. So these are all the whole highlight of embedded system design. Are you clear with this embedded system design? So I can move into explaining the other areas because I got a lot to cover. So I'll be a little bit faster. Muthu, yes, embedded is related into VLSI to some extent, but VLSI itself, it's a different field. But how embedded and VLSI is linked because the syntax, the programming logic, for example, the functions, the loops that you're going to learn, other various operators, operands. So these are all will be used same in the VLSI program as well. And also the timing analysis also. In embedded, you do simulation. Here in VLSI, you will be doing the timing analysis. So basically, there will be a minor link between embedded to VLSI. JK, okay, company is not hiring to the fresher. I'll show you how to approach in shortly in couple of minutes. So it's a different ball game. You got to approach differently for freshers. So which would be really helpful. So stay tuned till the end and you will know. Okay, so the next one in the technical hard skills is what is called the IoT, Internet of Things. And there are a lot of Internet of Things software out there in the market. The 3 major widely used in the industry is ThinkSpeak, Amazon Web Services, and Microsoft Azure. So with these 3, you can able to communicate your data freely, transmit and receive. So Internet of Things that alone, it's a major industry, and there are plenty of opportunities in the Internet of Things. And the recent one is now linked with the embedded AI. The artificial intelligence and the embedded are combining together now, and they are starting to write programs in Raspberry Pi and Jetson Nano. If you think of any video and audio application, so it could be either in one of these 3, Pink, Raspberry Pi, and Jetson Nano. If you already know a lot of programming, then you can target with AI jobs. But if you're new to the freshers, you can always start from going into learning this fundamental of any of this program and then any of this microcontroller, and then you can move into VLSI or IoT or AO, artificial intelligence. In parallel, while you do all of that, try to establish yourselves to learn about MATLAB, because MATLAB will give you more in-depth analysis of what really a project needs. Like its fundamentals will cover you how the signals, how the wavelength, how the frequency, how the amplitude, everything will be discussed. And in MATLAB, it will help you to do how you can process an image, how you can do signal analysis. And then from there, it's the machine learning and deep learning. And then if you're really well developed, you can start to do your app development, your own app. So while you study some software, also get into MATLAB, and that will also parallelly, it will be really helpful for you. And then the PCB design on its own itself, you can earn a lot of money by doing just this PCB design. which is also linked with embedded design. So the readily available Altium is the main source tool that we use in Australia. In India, mainly Cadence Arcade, and sometimes I seen KiCad and Eagle, and little bit of Mentor Graphics, but Altium is worldwide. If you know Altium, you can get jobs anywhere, but you need to get that initial experience. So that's why Altium is really a good tool to start with, but it is a little bit expensive on the other end. But there are other tools where you can start with. But take in any of these tools if you want to get into PCB design, and you can learn and you can design one of the boards. But before going into PCB design, if you are more interested into your own making design, then as a student, when I was studying, I used to make my own soldering and buy components and put things in a board, and then I fit my own components and test it. So that's how you design your own board. So you got your input uh, adapters, power adapters, and output terminals where you can connect to other peripherals. So that's your own board. And then there are some applications where you can try with. So these are all some of the applications where you can try with brain computer interface. All you need to have is some few sensors, and you can connect with your board and you can do programming. And at the moment, there are plenty of robotics going on, and self-driving cars. Yes, I'm based in Blue Mountains, which is closer to Sydney. There are self-driving car prototypes which I can see in the industry. In the road, I can see. At the moment in US, there are already on roads, and in China also there are a lot of self-driving cars. In India, the prototype is on. It could happen in few months or by end of this year. We will see some self-driving cars outside in major cities. And there are medical devices, industrial automation. So these are all some of the technical hard skills you can start to develop. So once you start to develop these hard skills, because most of you, sorry, I'm just stopping for one question and then I will come back to the session. How to get into VLSI if you're not from elite institutions? Okay, that is a very good question. VLSI alone, it's a big job or a big market oriented. So if you start with the embedded, do some more research, and there are plenty of resources out there. Go in there and try to find something VLSI and try to get some understanding and do one mini project or two mini projects. It's very easy. You can download the software and you can start in your own home, all those projects I'm talking about. Then you can saw that two projects. Whenever you want to get into VLSI, you can tell, okay, sir, okay, ma'am, I have went and I studied this, and this is my project to show to you. So if you have something on hand in proof, then definitely they wouldn't say no, you will get a job. Believe you me, when I started, I was like that. I took my own personal board that I was explaining to you. I showed that to my first employer. This is my job. This is the work I did. If you give me a job, I can do something parallel. And that impressed them because I put in my effort and they gave me a chance. So likewise, you will also get a chance. So this is for Siddharth. Okay. So while you develop your technical hard skills, you got to also develop your soft skills. What are they? Soft skills, when I say soft skills, you got to develop your resume writing. So resume writing, I don't want to talk much about it. I'll talk to you in some other time. And then start your own LinkedIn network, because these days the employers come in and check your LinkedIn and they headhunt you from LinkedIn. Depends on what projects you put in there, what applications you know. When I say applications, what programs, what tools like Altium or Embedded C, STM32 or ARM, whatever you know, put it there. People will know and they will look for you. And then you need to prepare your interview preparation beforehand. If you see a job ad, which I will show you how you can look at a job ad, try to get into their website and have a preparation for yourself. Study what they do and try to match what you are learned so far in your university, in your college. And even if you know one or two skills, then prepare, because at the interview, you can convince your employers that you have all those skills and you can develop, because that's what they look for your freshers, for your young minds. That's what they want to see, because they want to have that inner self, learning self. So they will give you a chance. And while you do that, communication skills in the industry is a must. That's why I'm conducting this session mainly in English. When you go in engineering, everything in every part of the world, this happens, including in India, you got to talk in English, because your clients, your potential applications will be somewhere, someone in UK or in America or in Australia or in New Zealand or in Canada. So you got to communicate to them only in English. So if you are good in or strong in only in your local language, you will find it hard. So while you prepare your technical hard skills, also develop your communication skills, because that will really help you to clear your interviews. And communication skills, you need to talk fluently in verbal and fluently in written. If you keep shy and if you don't try at all, then your skills won't develop. So even if you make mistakes, start to talk to your friends in English or to your parents, your siblings in English. You don't have to be perfect when you start. When you start, then you will make them perfect. So do that. And then time management, keep your time, keep your logs. So if you want to study today, stick by it. I want to study technical hardware today, or I want to study software tomorrow. So things like that. And finance control, be your own manager to control your finance. As you and I, we get plenty of money from our parents for our pocket money, and we spend our money unnecessary, like going out and buying junk food, for example, or wasting a lot of things. Instead, use that finance wisely. Go and look for some courses out there. Try to enroll into an internship course, because if you spend those 500 rupees or 1000 or 2000 rupees today, imagine that 2000 investment that you made will bring you 20 lakhs income or 8 lakhs income. If you hesitate to spend that 1000 in say junk food or pizza, or maybe just using it for video games, etc., whatever the case may be, it's for your own growth. So save that money, invest into a course, and that will give you authority that saying you did a project, you did a course, and the interviewer will know that you did the hard work, and if immediately you will go to the top of the list. If 100 people applying for that job, if you done that, they will shortlist you and you will be on the top 10, believe you me. And from that, you can develop your leadership and developing your own personal branding. That will all come in handy in the last. So if you are clear with soft skills, then please type soft skills. I will keep moving on. There is a lot to cover, so I don't want to miss any of these. Yep. Okay. Thank you, Yara. Thank you, Sai. Thank you, Vishant. Thank you, Rupa. Thank you, Parag. Thank you, guys. Thank you, Balaji. Thank you. Okay. Being an engineer, or if anyone for matter, mindset plays a key role. So you need to have a better, strong growth mindset, then everything will be in a flow. So when I say about mindset, it shapes you as a character. So you need to shape that character. You can say to yourselves, yes, I can do this. Yes, I can study. Yes, I am capable of. Always be in that positive frame of mind. So when you stay positive, even if you think that that project you can't really understand how the logics behind it or how they are going to unite it, you will understand eventually. So preparing your mindset is all about you. So you need to change that. And once you change your mind, then everything will come in a flow. So that's about mindset. And then while you start to study, you can also be a coacher. Like you can share your knowledge to your colleagues, your friends, because the moment when you start to pass your knowledge to someone, by subconsciously, that goes into your subconscious mind, and you become stronger in that particular area, particular concept, particular subject. So the more you teach to people, the more you talk to people, your level will also go. So please start your coaching, no matter what area you are in, second year, third year, final year, or graduate. If you know something, if you know that is going to be useful for others, please do pass that to others. So there will be a lot of people wanting a small guidance. For example, in some subjects that they don't know how to solve a derivation, so you can help them, show them steps. So these are all some other things where you can also do out there. I'll just stop for a minute. This is Ayush saying I'm not knowing anything about embedded system. How much time I can learn it and be industrial ready for a job? That is a very good question, Ayush. I have a very good internship running at the moment from my company, which I will talk to you very shortly. So it takes roughly about 1.5 months to 2 months. You will get a job, guarantee you. There are a lot of students in the previous batches. They all done that and they all got real good jobs. So I'll talk to you about that shortly. This is for Ayush. Thank you, Ayush. And about the other skills, so while you develop all that, then you can also start to develop your Excel spreadsheet, because as an engineer, you need to do plenty of data. So you need to know how to use Excel sheet. And then Microsoft Word, yes. Being engineer, you need to write reports, technical documents. We call the specific resources document, SRDs, in industry. And then PowerPoint creation. So if you design something, you need to present to your senior engineers and you need to present to your clients. So develop all these skills and editing skills as well. So all this will give you a very good pay in the end. So I put all of this in the summary, which I won't bore you with. So I'll show you quickly. I'll move back into okay, so we covered that pathway. We just discussed about the career pathways, and we have gone through the embedded system bank. And this is the three skills. If we have these three skills, you can definitely get into any industry in any application. First up is C programming. Yes, I keep stressing about C programming because that is the fundamental programming of any hardware programming language. Even if you go for VLSI, even if you learn VHDL or Verilog, if you know C programming, all the basics, the syntax, the loops, the function, operators, you name it, everything will be same, but different way of expressing a particular style. So that will be differing. So your major first skill is C programming. Then you can move into, as I was saying, take a one microcontroller, in that matter, STM32 or ARM microcontroller, because they are widely used in the industry. I'm not saying others are not used, but these two are really widely used in plenty of platforms. So pick one of those microcontrollers and start to do embedded C programming. So why I put that as second is, once you learn C programming, you can actually relate to write that in embedded C program. So embedded C program is all about writing particularly to that registers, which I got two projects to show to you. If you can stay till the end, I got two good projects, so I can show you a demo. So I would like your attention to the end, so you will get some benefit. So please stay till the end. Siddharth is asking, sir, coming skills is math, calculus are essential. I would say math is essential, but not calculus, unless until you are going into very deep network-oriented design. Calculus are very deep end. But if you know basic math, like addition, subtraction, modulus, division, multiplication, and if you know to convert number systems, all these type of basic math, which I'm going to show you in one demo, which you will clear. Most of you will get that demo shortly. So the third one of these skills is the PCB design. So which I said Altium is the widely used, and also Cadence or CAD or Allegro, and also Eagle, KiCad. These are all some of the PCB design. So once you know all these three skills, then definitely I can guarantee you for all your freshers, you will land into the job, and depends on how good you are, the pay scale will match accordingly. I know there are plenty of students who started from 4 LPA, and within about 3 months they moved to 8 LPA or 10 LPA because they are in the industry. So if they all can do it, you can also do it. So I will show you how, and I'll also show you a few examples from these sites. So I summarized these two sites. So I'm going to show you how much in industry in India alone people are earning. So just give me a sec. I will open this. Uh, there is a site called sixfigure.com. So you can also Google. I'm not making this up, but if you go to this site and in the search, just type keywords. So for example, I typed PCB design. I'll just close. I type PCB design and then click on search and look at the average salary for just a PCB designer or PCB design engineer alone. 22.4 lakhs. I'm not kidding. I know 3 students who studied way back and they are in that category and they only learned only PCB design and they can earn. So also if you want to go and look for say embedded, put embedded anything. So just give an embedded. Let's see what this software says. So they don't have any linked with the embedded or PCB design straight away. So you need to narrow down your search. So I'll remove the PCB skill. I'll remove this and then I'll just search with just embedded alone. Just by embedded salaries. See the salary 21 lakhs. So I'm setting 8 lakhs as a minimum. So once you combine all the three skills that I said, C programming, embedded programming, that is a microcontroller, and PCB design, you will be laughing. Literally, you will be laughing because once you see that offer letter, you won't believe your eyes. That is your worth. You can get to that sort of role. So how you know that you can get into jobs? Okay, this is the go-to job everyone go to in India from my analysis, Naukri. Most of you know how to get into Naukri jobs. Sorry, I got to stop. A couple of important questions. Santosh is asking how to learn PCB design for beginner. Um, if you're happy and if you can stay till the end, I got an internship course which is got also PCB design. I will cover that as well. And PCB design is also a very good field because this is for um Adarva. Yeah, Adarva. This is for you as well. PCB design alone, as I just showed you from this, it is a very good industry because there is plenty of design going on, multiple applications. So they need physically someone to do the layout job, someone to know where components should have to go. I'm going to cover the PCB design shortly. If you just give me a few more minutes, then I can talk to you. But yes, PCB design also, as I just saw, I will show again here, PCB. PCB design. And if you search here, look at the offer that we'll be getting. Just PCB. So just PCB salaries alone, look at the average salary, 25.7 lakhs. And if you're telling me if that's not best, for a fresher, for a first year graduate, for 2 years completing the degree, if you land into one of these jobs, then it is really, really good. And I got some pathways to go and achieve that. So it's all possible. So if you go to Naukri and this is the job, so just type in embedded C as fresher and click on search and look at the jobs there. There are 1,692 jobs available in India alone right at the moment. There are a lot of jobs for freshers. And if you go there, C program, embedded developer, 0 to 5 years. So freshers, And also they will show the locations, what they need, embedded C, software design, embedded software, like that. So because you asked for embedded C, so these will be all showing embedded C. If you look for PCB also, they will show all PCB. So I'll show you first the embedded. So this company called Aficionado Technologies, they are wanting someone with embedded developer with zero fresher. Sembotrix, see 0 to 2 years. Embedded system engineer, Indian Institute of Embedded Systems, 0 years, freshers. And look at here, 19 lakhs per annum for a fresher. All you got to do is invest yourself in an internship study, and within 1.5 months, 2 months, you will be there and you'll be knocking their door. Hey, I did my certification. I know all of this. Give me the job. And they would say yes, because they don't have to train you for 3 months or 6 months, because you already did your hard work. You learned all the 3 skills and you know already what to do. And that saves a lot of engineers in the industry a lot of money and a lot of time, because you put that effort already. So that's why I say invest your time in those 3 skills. And look at that. I didn't make this up. It's in the website, Naukri, and they are looking for someone as a fresher, 0 years, 19 lakhs per annum. C, debugging UART, I2C, which is all in the microcontroller programming, which you will learn eventually. Embedded trainee, Transworld Technologies in Pune, 0 to 1 years, freshers. Embedded systems, microcontrollers, C programming language, C. So there's plenty of jobs out there. Senior engineer, after you gain some experience, you can, and also 0 to 3 years. Embedded firmware engineer, 5 to 12 lakhs per annum in Udaipur. So likewise, the list keeps going. So if you go and search 2.25 to 3 lakhs for a design engineer, 4 to 7 lakhs, all this in Bengaluru, all this. So it's mind boggling. So when I studied 20 years ago, I didn't have this opportunity 25 years ago. That's most of the reason in my age group, a lot of us, we moved away from India and we moved to foreign countries because there are plenty of opportunities. But at the moment, India is bounded with plenty of opportunities. All I ask is you invest your time into developing those 3 skills, and definitely you will end up in any of these companies. Even in VLSI, okay, Muthu is asking for VLSI. Yeah, I'll show you this, and I can also do this job search. So everything 0, 0, 0 to 1, C, ARM, RTOS, embedded electronics design engineer, C, C++, embedded, so ARM processor. So as you can see, there are plenty of opportunities available there, and there are plenty of money as well for your own effort. Because somebody asked about VLSI, so I'm going to do a research here. Let's see what Naukri is going to say. VLSI, fresher, click on search. So even for VLSI, we call it as a physical design engineer, because I've been there, I done that. So I started as a PD engineer, and remember what they do in VLSI, backend design engineer. So you can do physical verification. If you know Perl, if you know VLSI, you can do that. And 0 to 1 years in Hyderabad. And electronic engineer fresher, 0 to 1 years in Gogan. Sorry, my pronunciation of some of these names are bad. I'm very sorry, but you can see what I'm showing. BTech, VLSI, ASIC, chip design, electronics, software. VLSI, 4 to 9 lakhs per annum. Digital design, Bengaluru, digital design. So likewise, there are plenty of jobs. And for some of you, if you want to also look for PCB design, yes, PCB, and look for search. In the PCB design also, there are plenty of jobs available. 0 to 1 year in Kolkata, 4.25 to 5.5 lakhs. Same in Apex Engineer in Hyderabad, 4.25, electronics and communication, embedded systems, RFIC circuit, PCB designing, Nagpur, junior PCB designer, Arcade, Allegro, PCB. So as you can see, there are plenty of opportunities out there in 0 to 2 years PCB design. LabVIEW. This is MATLAB as well. So 5 lakhs. So likewise, you can come into this site and you can develop those three, and you can earn a lot of money. Okay. So let me move on with my presentation. I got a lot more to cover. I'm going to give you 2 demos, which you will be finding it really useful. So allow me to show those 2 demos, so which you will get some idea. Okay. Siddharth is asking, sir, learn PCB designing on KiCad. I am able to design PCB with design for manufacturing, but I'm unable to land in a job, not even get interview schedule. Kindly help me with some practice guide. Okay, Siddharth, I will explain to you to all of the others the 2 demo, and then I will show you the what's available, so you can start with preparation. Okay, just give me some time. So first part of the demo is, how do computers know to recognize data? Do any of you know how it can be recognized? Can you type in the chat box, please? And I am giving you a clue. It's about C programming. How it can, your laptop, your computer, your mobile phone, how it can recognize any data, if that matter. Because we are all engineers, we are all design engineers, we are going to be design engineers. And in the industry, one of the interview questions will be this: how computers know to recognize data. I got this from a lot of my previous students who gone through that. Yes, here are zeros and ones and zeros. Ah, you guys are rocking, really, Vishan, zeros and ones. Yes, Govardhan, zeros and ones. Siddharth, yes, high and low, Vishan. I love this energy, guys. Like, you are really on the zone, so I don't have to do a lot of work on this. So, um, when you say zeros and ones, there should be something that a computer should know, how it can recognize at zeros and ones. And how that is done, do you know? Oh, yes, you're spot on. Yes, zeros and ones are error, it's binary, but there is certain processing has to be done before your computer knows. So which is my next explanation. Before going there, I would like to give you all the fundamentals. So when I go and do the demo, you would know all of that. So most of you would be knowing about C programming. Maybe if you studied in second year or third year, this is just a quick brush up. So general purpose language was created in the 1970s. They all started with the procedural structural control flow, which forms the foundation for all the modern programming languages. This is widely used in system software, drivers, and compilers, you name it. So this is where the computers come in. When I say how it can be recognized to save data, it's all based on what's called ASCII and number systems. So most of you would know. Yes. Muthu saying high level language to low level language. Yes. That's done in the system level, but actually, as a designer, as a developer, how you can tell something to go and save to make that application to work, that particular application to work. Yeah, there is a logic and an analogy behind it. So that logic is nothing but the ASCII. ASCII stands for American Standard Code for Information Interchange. So most of you already recognize that zeros and ones. So every zeros and ones represent a character, and every character has to represent to an ASCII value. And that's how you can tell to the computer, if it is that number, this ASCII has to be transformed. If it is this number, this ASCII has to be transformed. So most of you already know number systems are mainly fall into these 3 guys: decimal number system, binary number system, and hexadecimal. So most of you already completed your engineering, and some of you in second year, third year. Could some of you tell me what is a hexadecimal number system, please? Yes, man ASCII. Yes, Vishant, that's correct. So these number systems are used to represent data inside the computers. Okay, so yes, Rupa, you are right. Base 16, that's correct. Good on you. Well done. So we all congratulate Rupa. Good answer. That's good. So number systems are widely used in basically in this decimal binary hexadecimal format. But as a design engineer, as an electronics design engineer, we got to send any data in a form of a byte. We all know what a byte is. Byte is nothing but 8 bits. So we know what a bit is. That is your answer, binary. So all of you, most of you said zeros and ones. So that is a bit. If you send that in 8 bits, that forms 1 byte. And that's how computer receives any message to save. This is how basically it will be saved into your computer. So why I pushed to say, why learn C before embedded C? So the C teaches basic memory operation, how a pointers are used, how the control structures are used. And same thing you will be using in embedded C as well. The major difference is in embedded C, you will be directly writing it to a particular register for a particular peripheral, for a particular pin. So that's the difference between C and embedded C. C gives you to build the logical thinking in problem solving. So you will be doing that for a particular application in embedded C. So the same syntax will be used in embedded development. So that's why it's very essential to start with C. And then when you go to embedded C, you will find it easier. So there are a lot of data types in memory C. Most of you would be all learning. Yes, Rupa, there are 8, 10, 16 bits. Yes, you're right. So it depends upon the applications. You can use those sort of memory applications where you can go and use it. So there are characters, integers, floats, and doubles, as we know, as we all learn. So memory addressing and pointer concepts, which you will learn in C programming, which will be also used in embedded C. And important, so one of you has put in the chat box, sorry, it's running so fast I can't stop. Machine language to high level language, so which is the important register level in embedded programming. You are spot on. And then understanding bitwise operations is crucial. So that's why I talked to you about 8-bit and a byte. When you send zeros and ones, your computer or your embedded application have to understand that. So in comparison, so this is the two C between embedded C. In C, the libraries are standard libraries, whereas in embedded C, it's all bound for hardware specific, meaning for that particular microcontroller specific. In executing in the environment, it's all based on operating system based in standard C, whereas in embedded C, we call as a bare metal programming, which I will explain to you shortly. And in the standard C, it's focusing on general purpose applications, whereas in embedded C, it's on real-time control applications. You are making it to happen to make it for the real-time design. And in memory, you can say dynamic for standard C and also static or fixed, because you're going to work with certain memory in embedded C. So these are all the minor and the major differences between the two. So that comes to the computer representation of numbers. So being digital, you can imagine like a transistor. What is the function of a transistor? It can either switch on or off. So each operation, if it is a zero, as most of you already know, in digital, there's only two states, either high or low, or 1 or 0. So those two, think about a transistor. It's just like a switching, it's a number scheme. So this is the first demo I would like to show to you. So in the diagram here, we know, for instance, high, when you type high in any program, it has to convert to a binary sequence. Yes, from HI, the characters will be converted to a lot of binary numbers, which we don't know. And then if you want to see the same result back, you need to reconvert back into high again. So this is where the ASCII value comes in handy, which I'll show you the demo and the ASCII report as well. So for HI, H is a character, I is a character, and ASCII, according to the American Standards Association, has given H is 72 value, and ASCII for I is 105 value, which allows me to go and show this table. So if you go into Google and if you just ask for ASCII code, you will get this extended ASCII table. And in the ASCII table, so that's why I ask about the numbers. So here in the tabular column on the top, you see decimal number, octal, hex, binary numbers, symbol, HTML number, so on and so forth, the description. So according to this example, it has typed HI. So if we go and look for capital H, so the number equivalent to the capital H is 72 according to ASCII. And for I, which is a small I, if we go down, a small I is 105. So this is what I showed in the presentation. So 72 and 105. So I have a very good program which I already typed and made it compile. So I'm going to show you a quick demo so you will understand. So are you all ready to learn this first demo project? If you are ready, please type ready so I can show you. And you will see the magic about the conversion. Yeah. Rupa saying ready, ready, ready. Sangeet, thank you. Pranjal, thank you. Thank you, Jai Chandran. Thank you, Ayush. Thank you, Karthik. Thank you, Shantosh. Thank you. Thank you, Ishan. Thank you. Thank you, guys. You are ready, ready. Thank you. Okay. So, an open source tool, which I already opened in an online, if you go and type onlinegdb.com, I went before the session and I typed to save some time. So I saved all this typing for you, which I will run through quickly and I'll show you just the output so you know how the conversion is happening. So first, we all learn all this in the engineering, so I don't have to go very deep into each and every line. Just to understand the flow, it will make it understanding for you. Hash include standard input output dot header file. So remember, we are talking about C, not embedded C. So this is the standard input output and then string. When you combine plenty of characters, so you need to represent that into a string. So for that, you need to use a library, string.head. And then you need to do the math because we're doing to do the conversion between the character to decimal to binary, anything, whatever you want. So first up, you need to write a function to print binary of a character, because the computer only understands, or it makes it easier to understand in 8-bit as a byte format. For that, you need 8 bits. So you will be using 0 to 255. If you do the 2 to the power of 0, you know the 1248. I don't want to bore you with that. So if you do the math, to represent 8-bit, you need 256 bits to represent the 8 bits. So for that, you got to write this function. So void print binary unsigned character of, you need to start the loop int I equals 7, because we are starting with 0 to 7, not 1 to 8. So 0 to 7. So incrementing from 7, and then you telling the character to convert into binary. So this is where the first conversion starts. And then you're linking it with the 8-character binary string, because 1 bit at a time, you need to show 8-bit as one length of word. So you need to keep that. So for initial value, int I equals 0, I less than 8. So likewise, so you write a certain logic. And then when you come into the main program, you got to tell when the conversion starts and which format you want to see the output, etc. So you do all the logic, and you want to convert 8-bit to change into a character or whatnot. So then you need to come to this binary string back to text format. And after you done that, choose language to C, and then go and left click run. So this will start to compile the program. As you can see, now it is asking as an input, enter a word or sentence. So this is what we asked here. Printf, enter a word or a sentence. So I'm just typing randomly, welcome to this free webinar on June 15th, 2025, and then hit enter. Look at the conversion. Now the magic now really happens. So as soon as I hit the enter, ta-da, so this is what the actual computer will save. So I typed this whole sentence from here. Welcome to this free webinar on June 15th, 2025. Every individual bit W from ASCII, it has a value. Every character has a value. And that character is converted to binary. So in my computer at some stage, this value 0101011 is saved into my hard drive somewhere, but it knows that that value is W character. So likewise, welcome to the free webinar on June 15th. So all the conversion happens. And then if you want to re-see the message again, I converted back to say reconstructed text. Welcome to this free webinar on June 15, 2025. So this is about number system. And I have covered in an internship course about this number system in depth. If you are interested, I can share that to you shortly after I finish my other demo. I can share this with you so you can go and subscribe and you can learn how exactly you can do. And this is really, really useful for you. Because based on this, there will be plenty of interview questions. So if you know how to do this basic conversion, you almost cleared 80% of your interview. Being a fresher, conversion is the key. Because you need to know how basically your data is saved and how the computer knows to read. Yes, we all know how to convert binary zeros and ones, but you need to put that into a logic. You need to put it into a working sequence. By doing so, you can learn and definitely your skills will improve. So that's why I'm showing you this demo. Okay, let me continue back. So that's about character. But what is how the computer knows to represent an image? Do anybody thought of that? So you are seeing me or on your mobile phone, you are watching some image somebody sent to you, and how that image is sent to us or to the computer, to the mobile. Can you type if somebody knows how that image is saved and typed? Okay, I won't waste your time. So it is a simple logic. Okay, your images, no matter what size of an image, any image, it will work under a system called pixels, and it works in a grid, X and Y axis grid. So it will go, it depends on number of bytes and number of image that particular pixel is. So it will go like this 0, 1, 2, 3, 4, 5 in Y axis and X axis. So every pixel has a coordinates we call. So this particular coordinate to get green color, it will be called as 0, 0, whereas in this example, it's pointing to 1, 0. So likewise, if you want to see which pixel this is 4, 2. So XY 4, 2. If you want to see what color this is, pixel at XY2. So basically in the program, you got to use what is called a RGB analysis, red, green, and blue. And if you want to get a red color, you need to set that red as 255 number and keep the rest as 00. I don't have to go deep into the conversion. If you come into the program, the number system, I have covered all of this to give you very basic definition or with demo how you can convert. So it will be very, very useful. This not only here, when you go and do image processing projects, if you understand the basic conversion, you can go and do any video, image applications, any audio applications, etc. So likewise, for example, you see this dog. It's a smiling dog. We all love dogs, yes. So this is saved into my computer right now. But what is the magic? How the computer knows to give me so clarity with the dog, with a smiling face, with this wide open eyes. Yes, if you zoom really into this dog's eyes, can you see all these tiny frames? Small squares, blacks, grays, whites, these oranges. Can you see this? Yes, Siddharth, you are spot on. Matrix of tricolors of red, green, and blue. So each and every pixel in your image have to be programmed. If it is a 4 megapixel, you got to program each and every coordinates to get into this shape, this size. And this is where the software engineers in their programming language, they will make it more faster. And also this is done in embedded system as well, but we need to do pixel, pixel, pixel. So this is how embedded image is transformed to save into your image. Okay, so what about videos? Have you got any ideas about how the videos are saved in your computer? Siddharth is very good. Do you know the trick about the matrix of RGB? How about a video? You are seeing an MP4 clip, or you're watching a reel in your mobile phone. How is that saved into that particular device at that particular time? Okay, so we just saw first with the demo, a character is transformed to a number system, and that number is displayed accordingly, and that transformed to a binary sequence, and then that saves. And in image, it works in grid under 3 matrix, red, green, and blue. And in videos, it's nothing but those simple pixels. If it depends on 24 frames, there will be 24 frames of still pictures which will be running in a speed which our human eyes can't pick. So when that moves 24 pictures in that speed, that's what we visualize as a video. So behind that, if it is a 8 megapixel or a 10 megapixel full definition, all those categories will fall into that. To send that to someone, we need to compress the format and send it in a RAR format or zip file format. So that's how the videos are saved into your computers. For example, this is a 4K LED TV, for example. So a 4K is nothing but it has 3840 pixels by 2160 pixels. So if you take each pixel, so you need to program 3840 by 2160 to give the full video occurrences. Likewise, so there are some lot of resolutions which you would see. For example, the widely used 4 megapixel or the 4K resolution, which when you go in to talk about aspect ratio, it will all come in handy when you do video applications. So this is how starts from the basic, from a character, transform that to a ASCII value, transform that to a binary value, transform that to a pixel with the image. One pixel makes plenty of pixels, make an image. One image, plenty of images makes a video. So that's the basic of it. How many of you think that this is really, really interesting? So please type in if you don't know before, or if you haven't seen anywhere, then please type it is interesting. Yeah, I'm sure most of you are not aware that this is how really the conversion happens in the back end. This is how this knowledge you would get it in the industry after you go through say 4 or 5 different projects, which I'm passing it to you right away here. So so you can also start with your basic understanding and you can jump straight into projects. You don't have to do any other major learnings for your likes. So for example, if you go into videos of number systems, into this 1080 pixels, so that size, so you need to program 1920 by 1080. A 4K resolution TV has to have this 3840 2160 pixel. That's why at home, when we watch the TV, the clarity, it looks like you are looking at a mirror, sort of crystallized clarity. It's because it will have this particular tiny gray corner here will be programmed, and it will have 3840 times by 2160 times of images into this tiny spot. So likewise, it has to multiply. And these days with our programming, you need to write only one sequence and it multiplies and gives you the result. So which is really, really mind boggling. So this is all about the videos. How do we do a music file storage? Okay, you are listening to me. You can hear me through my microphone and you can see me through this video, how this audio is saved. For example, we are listening to music, sometimes radio, AM and FM. Okay, so every time when you hear me, I have a modulation. My pronunciation varies. So at each and every point of modulation, the microphone picks up my modulation and accordingly it sets a value starting from 0 or negative or whatever value. Accordingly, that will be converted and saved into your computer. AM stands for amplitude modulation. So the modulation, so it goes from high to low. So that's the amplitude. So if you listen to AM radio, so this is how sometimes you hear that it's breaking up, so you won't get the full word. So that depends upon the signal and the antenna area as well. And frequency modulation, because repetitive speed, frequency is nothing but speed. So they calculate the time. So the more speed it takes, so we get clarity of FM radio. So that's the main difference between the audio. So this is how the computer actually saves the music files, the audio files, the video files, the image, whatever. So now you know all the three basics. So every project that you're going to carry on for your rest of your lives will be based on these three major categories. Either it can be an image, audio, or video. All this based on number systems. And I covered these number systems in the C programming internship course. So please to stick by me and I will tell you shortly. So most of you, if you are from the 80s, 90s, yes, Mohammed Zubair, you are correct. I got a demo to show you how a to D conversion happens. If you can bear with me a few more minutes, I can show you with the demo as well. So yeah, you are right, Mohammed. Thank you. Okay, so do any of you have any idea about how a CD or a track system works in Blu-ray, if that matter? How the music is, we are able to listen, how that music is bound to be happening. Okay, so if you put the CD or DVD or Blu-ray into a microscope and if you watch it through a microscope, you will see tiny spots of this dimp and there will be a empty space and then there is a dimp, and there is a empty space. So the laser, which on the drive, there is a laser light that projects and hits into this CD disk. And whenever it hits and bounces back, that means it's a 1. So it will pass on that message. And whenever it hits and no bounce back, that means 0. So these dips are nothing but zeros. The flats are 1. So it depends on number of zeros, depends on number of ones. Your music varies and depends upon your amplification or frequency, your different sounds happen. So this is the logic behind it. So next time when you see any DVD or any Blu-ray, if that matter, go and put it under a microscope, you will see this. So this is how the magic happens. So all in the end comes to number systems. So we got to be really good in how the conversion system happening in our head. And also when we talk about engineering, how this A to D, the analog to digital conversion happens. So all of this makes sense in a short while. So that's why I said the career path from you can start to learn from standard C and then move into embedded C and then pick one microcontroller. Then you can learn to do real-time operating system. And when you want to develop drivers, you can jump into Linux and you can start to develop that. You won't be able to do this in one day. It all takes time. But If you are dedicated and if you put your time in, your effort in, you can be a master. And there are some project ideas. You can start with your home automation. You can do for your own house, sensor monitoring, industrial control systems. Start with simply blinking. Try to blink an LED, see how the on-off state works. And then eventually you can build up to an IoT system, which also in my internship program, I got a project with IoT system. If you really are interested, I can show to you shortly about the internship program that we have at the moment. So these are all some of the ideas which will help you. And for most of you, for freshers, if you are thinking, how am I able to get a job? Again, I'm saying invest your time, invest your money in learning these three skills: C program, microcontroller programming, PCB design. And I showed you, you can start with 9 lakhs to 12 lakhs. And over the year, even I know a few friends by end of their first year or second year, they got salary hikes to 12 lakhs or 15 lakhs, if that matter. So yeah. So with that, I'll move into the second one, which is the microcontroller programming. I'll rush from here, so I need to cover a lot. So please be patient with me. Hari, unfortunately, this recording is not shared, but if you do go into our YouTube channel, this is will be in the live session, so you can revise it in our channel. But unfortunately, Zoom doesn't allow me to record this because being educational, they don't set us to record. So I'm sorry. You can watch it in YouTube. This is for Hari if you want to catch up. Yeah. So embedded C used for programming, as we know, to program microcontroller. And I covered one big microcontroller STM32 in my internship program. Stay behind, I'll show you the internship that's running at the moment, which will be really beneficial for you. And it interacts with the IO pins, meaning as I just explained with this chip, this is a microcontroller. So this is where the microcontroller programming comes in handy. You directly program into the pins, the IO pins, and which is connected from here to other peripherals like ADCs. Mohammed brother already said analog to digital conversion. Thank you, Mohammed. Yes, because we are talking about number system conversion. So I'm going to show you in related to that how you can convert an analog value to a digital value in a short while, which is really interesting. And there are plenty of timers which is in a microcontroller program. So you can start with something like blinking an LED, reading a sensor data, sending serial data likewise. So we learned in C program, think of a transistor being an on state and off state. In the hardware control in embedded C, we set the bit or we clear the bit. Setting the bit is to set the bit you are turning on. Clear the bit is simply you are turning it off. And this happens in every embedded system. So that's why I have given you example from C point of view. Now you have the relation, how that's all linked with embedded C. So now when you go into microcontroller programming, after you finish the C programming, you can make sense. Oh, okay, so this for loop is used here for this purpose. Okay, here I'm turning on, waiting for 8 bits to clear, the output is coming. So that sort of connectivity will happen. And ASCII all used in embedded displays as well. So the LCD character display. So for example, I have a two-piece LCD, which also I covered in depth in the internship program, how you can code this to see any display messages into your LCD, and how you can send messages to other peripherals through UART, USART, you name it, keypad encoding if you want to give user input, and data sent and received using that ASCII format. So that's why I touch briefed all of that in embedded applications. So before moving into PCB, which is the third part of this free webinar, I would like to give you a demo about ADC. So are you all ready to see a magic with how analog can be converted to digital? If you're ready, please type ready. I will show you this demo. I won't go and bore you to type each and every line because that takes time. I'll run through this project quickly so you will just see the output. Yeah. Thank you, Siddharth. Thank you, Mohammed. Thank you. Thank you for all of you guys for staying back. I know this is Sunday. You can do a lot of useful things and you got family time, you got friends to catch up. But I'm sure you are already feeling some value that you are here to learn something. And I'm sure if it is worthwhile, can you type some energetical messages in the chat box so I know that I'm not wasting your time? Something that a word that encourages you. Are you really interested in learning this sort of free webinar session? Are you learning anything today? Is this really interesting? Type something. Yes, please. I'll just have some water in the meantime. Yep, thank you. Thank you, Kartika. Thank you, Shantas. Thank you, Siddharth. Thank you, Shwati. Thank you, Surya. Thank you, Atif. Thank you, guys. Okay. For the STM32 microcontroller, what we have a environment where you can write a program, which I covered in the internship. You don't have to worry about it. In my internship, I covered each and every detail to the basics. So you don't have to even ask anyone. When you go through, watch those videos, you will learn how to do it. Okay, so the first part on any program, it's all about comment so and so who have written the program, what program that is, which part of that program. Because in industry, when you write for an application, there will be 20 different projects. So for example, in this, I have got 30 days worth of programming in here. So in this comment, it will be highlighting something along with license files, as you can see. So that's very irrelevant, but anyone in your team, if they want to come and see, if they read just this top comment section, they would know exactly what this is all about. Okay, so as we saw in C program, we need to use there the standard C. Here it is real-time library, which is, excuse me, specifically bound for STM32. So this library is different to the other library, but the syntax look, hash include standard int dot h, hash include standard input dot h. So the C and the embedded C, so that's why I give you the connection to show that program to this program. But there you have written a variable, writing a character, a word, or a sentence, whatever that is. Here you go and write each and every register, which don't worry if this is too complicated. Right now it may look complicated, but in the internship I explained each and every step, every concept. So this AHB1 ENR or APB2 ENR, these are all registers which is connected with your okay, for your information, being a design engineer in the industry, you need to be like if you study any book or if you listen to any podcast similar to that, you need to be really thorough in your data sheet. Data sheet is like your go-to guide. So if you come to a data sheet, which I also shared in the internship as well, STM32F411RE, page 15, I will maximize this. So this is the overall block diagram. And we are talking about ADC, which is, if you come here, so these are all buses. So AHB1 bus. So this is a register which is connected via the AHB1 bus and via GPIO port A. We're going to use the input-output port A for this demo. And if you still come down, you will see all the peripherals like timers, USARTs, SPI, likewise USART2, I2C. So likewise, if you come right down, there is the ADC peripheral here. It is a 16 analog input. As you can see, it is connected to APB2, which is a peripheral bridge bus, which I explained in detail. I won't bore you now. I'll just show you the demo, but I showed you where exactly and how exactly where you got it. So here, when you click on the window, if you go into SFRs, the special function register, so that's where you get the name. So window, show view, and if you click on SFRs, so this is the window all registers. So this is where I got all these numbers from, or these names from. So if you go STM32F411RE, yeah, and if you keep going to GPIO port A, because we're going to use GPIO port A, and these are all the ports we'll be using. So we need to go to this port, PHB1ENR. So if you can't find it here, then you can type in HB1ENR. So it will exactly take you to that location, and you can just copy and paste it. So that's how you can type in. So I have written all of that for your simplicity. So to convert your analog value to a digital value, you need so many registers, for example. So accordingly, I have taken everything. So you need to connect. If you want to talk to your microcontroller, everything in microcontroller talks by bus, which you will learn shortly in that internship program. So likewise, everything as we already learned. By the way, this STM32 is a 32-bit data storage. Everyone will start with 8-bit, but I want you guys all to jump that bandwagon and move directly to 32-bit, because everyone will start with 8-bit. Learning 8-bit is very easy because you're playing with only 8-bit. But when you learn with 32-bit, you can easily adapt to 8-bit very, very easy. So that's why you need to put that extra hard steps. But don't you worry, I explained everything in detail, so you don't have to worry. So this is the 8-bit. So for this particular register, this value comes from here. Look, 23830. So this is the value. 4002 23830. So that's the value 23830. So likewise, you need to go and find for APB2. You get a value. GPIO A mode R register, a value. ADC1 status register, a value. ADC1 control register, a value. Likewise, sequence register and a data register. So once you get all the registers that you know, by the way, when you go to registers, how you know what registers you want? The second one you have to go to is what's called a reference manual. So there is a STM32. Each and every microcontroller, by default, the manufacturer will release to the market for us users data sheet and reference manual. So you need to, as early as I said, the associate engineer, project engineer, it's their job. They have to go and collect all this data sheet, reference manual, technical documents. So you'll be spending the first, bigger companies spend 6 months of your time to go and analyze all of this. So you already have that 6 month worth of experience already, you know exactly where to go, what to find. So I want you to be more confident that by end of this session, you already got that 6 month worth of experience. That's what you're getting, more than 6 months by the time I finish. Okay. In the STM32 reference, if you go to analog to digital converter, it talks about what you want to know basically, if it is a 12-bit, 10-bit, whatever the case may be, and what are all the registers you need to use if you want to do the on-off control, the ADC clock, etc., etc. So this is where I got the idea and I collected all this. You will also get it when you watch the internship, because it's a long process. So I'm just running you through quickly, and you will know how the conversion happens, etc., which I'm going to show you in this code. So this is where you can find all the information. Okay, let's go back to the code. I will explain. So this is the logic. First, you need to initialize everything. As you can imagine, if you want to restart, you need to reset first. First, you need to initialize. So to initialize, there is some certain steps you got to follow. First, you need to set the bit and then enable ADC, telling the microcontroller this is for the ADC bit that it's coming, bit 8 to 1. And then you need to set, okay, this is the board I have. This is the STM32 board. By the way, if you need a hardware, I will share you a form later, and you can send me your request, and I can source you some good hardware for you to start your projects. So I'll talk to you in a minute about that. So likewise, it has got 5 channels. If you see closely, I don't know whether the camera can pick these connectors. Analog 0, 1, 2, 3, 4, 5. There is 5 analog pins which can be used for your digital conversion, analog to digital conversion. So for that, I am using port A, pin 1. So this means port A, pin 1. So first we need to disable the previous values, whatever the value I already posted. Then you need to send the sequence. This is where, remember we talked about 8 bits. So here it is a 32-bit. So you need to send 32-bit of signal data in there. And then start the enabling to get the sequence and do a simple for loop like a delay you need to give. And then this is where the conversion happens. So I need to initialize, print the value, and then you're going to set this bit 30 as 1 because once the 8-bit receives, 32-bit receives, it will start to do the conversion and it will keep it into the analog value, and whatever analog value will be converted here and it will be displayed into the digital value. I'm going to do some hardware connection. Just give me a sec so I can show you the output there. Just one moment. So I'm connecting the port A1 at the moment. So by the way, sorry, I'll show you this. So you can use a simple variable port. So I got a port. It's an analog port. You can vary either left or right. So this is what I'm going to connect. I'm sorry, the other camera, I'm not able to connect my other camera, otherwise you can see the other view as well. But yeah, imagine you are trying to connect. So I'll connect it. So A1 connecting. And don't worry, I have explained everything in the webinar, in the internship. Then I'm connecting to the ground pins and the power pin for this particular port. It needs a 5 volts, yes. Okay, I connected the hardware, so I'm going to go here. So I know by writing here, it's an ADC program. So I'm going to right click on the ADC program from the project window. This I already all explained in the logic there. Click first build the project. So this will check for any errors. And this is your output window, which will show everything. So 0 errors, 0 warnings, which is really good. So now we need to move from the program mode to the output mode, which is again, right click on the project. Sorry. And then you have to go here as run project. So run as a STM or run configuration, doesn't matter. Or you can go directly to debug or debug application. So let's say we can debug first. So I'm starting an STM32 application, which a small window will open, which will ask for couple of things which I'll show to you. So you can't see here, it's 79% here. Yeah, it's waiting for the debugger connection. Okay, at this moment, it's asking me to switch, which I clicked. And this changes from program point of view to the output point of view. So when this download verification successfully happens, so we are in the debug mode. So after it finishes, 100%, yes, it finished. So it's ready for running. So once it's ready, so I'm going to come here and then click on resume F8. So watch what happens. So I click F8. And before doing the F8, it will ask for print F8 display ADC value. So you need to enable a couple of options. So you need to go to window, show view, and you got to enable the trace because we are going to watch the output. So don't worry, all this explained in the internship. I just wanted to show you how this works. So look, already the conversion started happening from my potentiometer, as you can see. So I'm turning the knob in one way, 4096. So this is analog value 0 to, it's a 10 bit, so that's why you can get 4096. And I'm going the other way. Look, it's almost down to 0. So this is how actually the number system happens. My analog value from that switch, from that potentiometer, it's changing. And you can see, as you can see, 4056, 406275, all this happening. So this is how actually the analog to a digital conversion. So you can use this analog digital conversion in any of your applications. And one good example, if you want to see some intermittent value from somewhere, you can use this project. You can use into in that application. So you can capture all this value. So which I have explained in the sheet in the internship. Okay. So I hope that was useful. So this is the last thing I will explain to you. Then you will get the whole picture. So I talked to you about earlier about PCB design. PCB design is nothing but it mechanically supports and electrically connects components. So you will be designing in my internship course. I specifically I think some of you asked you are not getting any jobs or anything, even though you learn KiCad. KiCad is different to learning from Altium because Altium is the industry tool which every employer wants you to know. So in my internship, I have used Altium Designer, and you would be able to design similar to this: one input, two outputs. So one voltage, you can get two voltages. You can use this board for your mobile charging, for lighting up your simple applications, whatnot. So which I will explain shortly. So definition, as you can see, mechanically supports and electrically connects different components all together. It is the foundation for all electronic device. You name it. Even your mobile have a PCB board. Your watch, smartwatch has a PCB board. Your computers behind that motherboard is a PCB board. Your camera inside that, it's a PCB board. Your camera, web camera, everything, whatever you think of, any electronic gadget will have some sort of PCB in there. So that's why PCB on its own, it's a big field, it's a massive field. And I show you people are earning 25 lakhs just by doing PCB design. So the functionality here is to translate circuit diagrams into manufacturable layouts. One of the brothers said he learned KiCad with DFM. So likewise, when you learn that in an industry recognized tool like Altium, the KiCad DFM, there will be few steps will be missing. In Altium. It has got every steps covered. So in the industry, that's what they'll be using. So already you got almost 1 year worth of experience by going through designing just this simple PCB. This takes in the industry, believe you me or not, it takes more than 6 months for a dedicated team to design this. But through my internship course, you can design that on your own. You don't need anyone else's help. So I design such a way that you can also do it. Okay. So this is the stages of PCB design. It starts with first requirement analysis. So that's where, again, the associate engineer, project engineer comes in. Their main role is to requirement analysis. And then there will be dedicated hardware team where they will be doing schematic design and other things. But in small companies, that's the joy of attending or joining a small company. You get a chance to do everything by yourself. So you will be learning a lot. And that's why joining a small company is a big advantage, because by the end of a year or 2 years, you know everything. And you can simply ask for 25 lakhs, 30 lakhs easily. So that's how some of my students who studied and did this internship, they only did 1 year, 2 year experience in some companies, and they all now moved to even abroad countries. So that's why I would like you to be like that, and you can also enjoy going outside India and doing plenty of interesting projects. Okay. Then the third in the analysis stages is component placement and routing, which I have explained in the program itself, and design verification prototyping. Finally, the DFM, manufacturing and assembly. And again, if you talk about PCB design, there is a single layer PCB and a multi-layer PCB. This is a multi-layer PCB, which you will learn also in the PCB design. And also, you're going to learn about Altium Designer as well, one of the highly needed tool in the industry. So what is Altium Designer? I just told you about Altium Designer. Altium Designer is a professional PCB design software. And I think now the version is Altium 24.12, I think. When I started learning, when I came into industry, it was Altium 13, Altium 14. So down the line, it's now to Altium 24. But you got to know only one version. Every version is identical, if not similar, just few commands, few instructions will change, which you will pick up very quickly. It's not that hard. It's not really hard. You think it's hard to learn Altium Designer? You are an engineer. You learn 4 years of degree course. If you can do that course, learning about 60 subjects, learning about 12 practical subjects, Altium Designer is so simple. You can learn. If you dedicate just 2 full weeks, you will be a master in Altium Designer, master in PCB design. So that's what my students previously done that, and immediately they got a job. So that's why I want you to be. So I'm giving you this. It's nothing but an unified environment where you can see this is a schematic layout we call, where you physically draw circuits. Remember, in our engineering degree, we draw on a diode, we draw on a resistor, capacitor, transistor, things like that. Here, with this help of the tool, you will be designing the actual component itself. For example, if you want to design this 3-pin potentiometer, you can design that. For example, if you want to design this battery, you can design that. So everything comes in this layout, starts with the schematic, then you'll move into do wiring connections. And the beauty of Altium Designer is you can see in a 3D visualization. After you finish it, you can actually move your board in the software to see what it looks like. So this board, after you finish the design, you can actually see how it looks like in the software itself. This is what I did, and this is what I got in my hand. But this is what you will be doing in the tool itself. And these are all used by very big top companies like Intel, Bosch, etc. They're all well established in India itself. Intel has a big unit in hardware design, so as Bosch. These two are really big when it compares to embedded and PCB design. There are plenty of other companies. And also with VLSI, you can target Qualcomm. Intel also have a VLSI ASIC jobs. Samsung, Mentor Graphics, Synopsys. There are plenty of companies in Bangalore, for example. You can target those companies. So what are all the key features in Altium Designer? As I said, it's a unified environment which has everything, which has the schematic, layout, and the 3D visualization, and everything is designed for manufacturing purpose. And as you can see, this a very good friend of mine, Ryan, who asked to share this small clip. Top is the component and bottom is the track we call. So copper track side to the opponent component side. And you can do the 3D visualization, real-time PCB rendering. So after you design, okay, I went and manufactured and got this from the fab. So if I don't have this, imagine this is how it looks like, your board, something like this. It will look after you finish your design. And not only that, while you do, there are certain steps you need to follow to make this board actually work, and it won't produce any short circuit, it won't produce any shocks to your hand, or it won't damage any other appliances in your house or wherever you're going to use. There is what is called a design rule check inside the software. It will go and check for short circuits. Is there any crosstalks? These you will all learn from the internship, which I'm going to show. What is this signal used for, etc. Everything, which will be all very interesting. And career point of view, that is, these are all some of the things which you will only after you get the job, only you get into the industry, then you will know about all of this. But going through with my internship, you already get at least, I'm not kidding you, 1 year worth of experience in that short courses. Okay, so what you will be designing is nothing but it's a SMPS. So most of you know here what a SMPS is. SMPS is switch mode power supply, meaning you are getting an input of some voltage and you need to convert that to a certain voltage. So this is a single input dual output. That's what you're designing. So we need to design for purpose. So with this, you can design, well, I have designed into 3.3 volts and 5 volts. Accordingly, in that program, which you, if you are interested to learn, which will be given in, I think, 4 different variations. You can use for 12 volts, 9 volts, 5 volts, 3.3. So you can choose. So I'll give you the run about the SMPS. So how it works. From the outside transformer, that's when you plugged into the AC, the mains, it will start to rectify first. First, it will change to low voltage. That's what the transformer does. In the rectification, it will still further down with the, from the output waveform, it still reduces to DC. And then the filter will make it more smooth. So it will have a small filter, and the regulator helps you to just regulate that 5 volts or 12 volts or 9 volts. So basically, this is a simple block diagram, what this does. So for example, all your charging adapters, I don't have any adapter with me. You know, all your phone adapters, it's so tiny. So inside the tiny adapter, you will have a similar board, something like this, with a USB output on one end or a lightning end or a USB-C, whatever output pin you want, you can also nominate. So that's how the adapter is designed. And if you really become good at it, you can get your own IEC certification and you can do your own freelancing PCB design. There are plenty of freelancers in the market. If not, they are earning more than working for a company. I know about 3 or 4 freelancers who work in Bengaluru. They earn 35 to 40 lakhs. Very easy. Yeah, so that's why I'm giving you the head start so you learn from one design. So in nutshell, the SMPS design in the Altium Designer, you will be using something like this, and you will be learning how to use a schematic symbol creation, which is the outline of that component. And you will be learning to use footprints. For example, if you see the top view of these connectors, from the top view, you need to see where those 2 screws going, where those connectors are going. So from the top view, you need to give that area. So that's what we call as a footprint. So for each and every component, you got to design your certain footprint, which I have explained everything in detail. You don't have to worry, but I'm just showing it to you what you have to do. And then from this design, you will be moving to designing and routing. It's called optimized layout and routing, which means you will be placing components, and through that you will be connecting wires from one end to the other end, which you will learn. And also it comes with a simulation to perform thermal analysis, because in any design, heat dissipation makes the efficiency to go down. So you need to know which component is getting super hot or where too much of the voltage is going somewhere. So the thermal analysis will give you that. So this Altium Designer has the built-in functionality. With one tool, you can do all of this. So that's why universally it is worthwhile used in every industry. Not many course providers teach you Altium Designer. I have gone across a lot of resources somewhere. So most of the people teach you only Cadence. So very little people, if not, you can number it 1, 2, or 3, 4, maybe 3. Because it takes a lot of time to put one Altium Designer course for you guys to learn. Because it takes behind the scene a lot of things to make it more understandable for you to learn. So that's why not many people go for Altium Designer. But If you learn Altium Designer, your job is almost guaranteed to get a job. So when you talk about practical SMPS design tips, you will be placing and you will be routing. And for heat dissipation, you need to put a lot of vias, we call in the industry. That's to dissipate some heat so your components don't get heated up. So the components are placed close to each other, so you don't have to have a massive board. Imagine you can fit this into a bigger board, but the the simplest board, the shorter board, the cost of this price of making this board is reduced. So you need to be more compact, and you can go double-sided likewise. So eventually you will learn all of that. So and then you can use one ground plane and one proper isolation plane, which you'll be learning. So this graph gives you a different career opportunity, average salary per month. I just did analysis, and in Asian countries, India is the top salary-wise in PCB design. As you can see, as soon as you get in, you will get at least 35,000 rupees per month, at least. And over the time, that will go into 1 lakh per month. I know 2, 3 friends, 3 batches before, they're all earning 2 lakhs per month. So likewise, Mexico, Turkey, US, UK, London, I didn't put those, but I just wanted to give you some snapshot. Bangladesh, Bhutan, Sri Lanka, Pakistan, Nepal, everywhere. So as you can see, it's widely used. And industries, any that you name of. Roles, PCB design engineer, embedded systems designer, embedded system design engineer. Global demand and the career growth for this particular industry is massive. So please jump in and invest into those 3 skills. Definitely, you'll get a job. So how the salary trends for PCB designers? I was Googling, and I was getting some input from my known sources. So as you can see, the top roles in PCB design, just by doing a PCB design engineer, you get 8 lakhs per annum. And after being a design engineer, you'll move into what is called a validation engineer to make sure that hardware works. For that, 10 lakh per annum. And once you are a master in both, then you'll be the hardware design engineer, which is the top end, the front end engineer. By this time, when you master all these 3, then what you call as a embedded system engineer, which combines both software and hardware. And that's where 35 up, 40 lakhs, 50, 60, you name it. So there are a lot of freelancing and senior roles available there, and can earn more as well, depends upon your experience and your expertise. So how to start a career in PCB design if you want to just start only in PCB design? So these 3 are really hot in the industry. Go to their websites, TCS, Infosys, Wipro. Every year they employ freshers from uni graduates. Talk to their HR people or talk to their team. Before going to talk to them, please get into the internship that I'm going to offer to you, which will give you that confidence that you can go and talk to them and you know stuff. Because at each and every internship program, I have compiled what are all the possible interview questions they may ask and what sort of approachable answers that you need to give. I also covered that. So it is really worthwhile, and it is really useful for you guys. So that's why I dedicated my Sundays to you, so that it will be all useful for you. So learn tools like Altium Designer, practice with the real world projects. So this SMPS design alone, it's a real-time, real-world project. You can tell anyone that you design a switch mode power supply. You know, in the industry, once you say, oh, you know to switch mode power supply, that's one of the difficult conversion, if you like. That's why I started from number system. So similarly, switch mode is not easy, but you will learn to design that. And once you start with one PCB design, you can multiply that and build a strong portfolio, and that will get your necessity. Okay, so about me. So you so far, thank you so much for listening to me. So who am I? I'm based in Sydney, Australia. I got now 25 plus years experience working in this industry. That's my LinkedIn profile. If you want to follow me with LinkedIn, I can share you my LinkedIn. I worked in Italy, Singapore, and in India. My background is from BTech ECE. I studied in Pondicherry University back in 2001, 2002. I moved to Melbourne, Australia to do my master's. My majors is in VLSI and embedded system. I studied from Victoria University, Melbourne, Australia. Since then, I've been working in plenty of R&D, renewable energy companies, network embedded system companies, and a lot of banking automations and smart parking operations. As a nutshell, I acquired all this 25 years experience. So that's why I put that out into the 3 skills that I summed up into an internship course, which will be really helpful for you. So this is about this. This is A2DG. This is our company. So I'd start up with my brother, Alex, and I. Alex is my elder brother. He's in IT, and both of us started to do online mentorship and consulting. Now we are doing into digital marketing. My brother has over 30+ years experience. And our mission is to convey at least to 100,000 future professionals, like from your college, your district, your state. I would like to educate as many number of students as possible. So we have a empowering India or empowering electronics industry, so we can go and impact a lot of people's problems with your design. What you're going to learn, what you're going to design will solve a lot of people's problem. So that's how you should be. That's how your mindset should be. You need to develop your mindset. Yes, I'm going to invest on certain skills today, but that's going to bring me a lot of revenue in my long run. So that's how you need to think and act. If you're interested, please do follow us on our Facebook, and we have our Instagram, and we have our own dedicated YouTube channel, which I will share all the links shortly in the chat box. So if you stay till the end, I'm going to give you a free ebook. So please stay till the end. It's not much to go. Just thought to give you a simple definition about embedded system. Most of you would know. So what is an embedded system? It is nothing but a combination of both hardware and a software. Like in this case, this is a hardware. You have to write a program to make the software to make the two step down voltages to work. For that, you need to write software with some associated mechanical parts to perform a specific task. So this is nothing but in a nutshell an embedded system. A desktop as a whole is not an embedded system, because with that you use multiple applications. It is not. Whereas a printer system, a washing machine, or a microwave, these are all specific related. It only does for that particular application. So that's why that is a different embedded system compared to desktop. Okay, so here is my chance to ask you some questions. Can I ask you all these questions? Are you ready? If you're ready, and if you find this all valuable, then with your permission, I would like to all these questions. Would you like to want these courses as in a format of recordings to you? I have put through almost 1, 2, 3 courses, so almost about 60, 70 days worth of recordings in there. And I have categorized all the course materials with the source codes and all the PDF materials, the data sheet, the reference, you name it, all in a rare format. If you'd like to have this, then if you want to have a dedicated doubt clearance session directly with me, either on a Saturday, or we have a dedicated WhatsApp group, you can come and ask doubts in that WhatsApp group. Not only that, there is a LMS system where I set all my previous subscribers, they come into this WhatsApp group, they share their industry knowledge, what they learned, and they help each other, which is really, really helpful, because it helps you to solve your doubts, and also you know what's happening out there. And if you want to have a clear roadmap, which I shared now, like the career pathways and embedded, you can also do so. And today I'm offering you a 3-in-1 course bundle. And here we go. The first course, I talked to you about the binary number system and all of that. So you will be learning about to use a DJGPP compiler, which is really a good compiler, and also Programmer's Notepad. And I spent 2 full days to give you a lot of insights about 6 different projects. 10 days plus 2 days of projects with that value. If if anybody goes into my website, they have to pay 999 for this one course alone. But you are here, I'm going to give you in a bundle. So please wait till the end. I'll announce you the bundle. Then I was talking to you all about I microcontroller programming. So STM32 is a widely versatile used programmer out there, microcontroller. It's based on architecture ARM Cortex-M4, which is the high standard. If you talk about standards, this is right up there. So you will learn the complete architecture project. You will start to learn from how to blink an LED and control a switch, and then you move on to learn all of these mini projects. The ADC is showed to you how you can convert. You will also learn there step by step. Plus, you will learn what is a startup file, linker scripts, and communication protocols. Not only that, there is two major projects I have summarized, everything from A to Z. One with Bluetooth home automation. Second is the IoT with the Wi-Fi connection. And also you'll be learning IoT cloud software about ThingSpeak, how you can transmit your data and how you can see that. Not only that, you will be learning few other projects about how the LCD pulse width modulation and how you can communicate to the other applications. If you go into my website, you have to pay $14.99 just for this course. A lot of students purchased for this course. And the PCB design, which is I put through a lot of effort to give this SMPS, and you're going to use Altium Designer. Altium Designer comes with a student trial version for 14 days. They give you 15 days. And this full design, you need only 8 days to learn and then 8 days for implementation. By the end of 15 days, you will be able to design exactly this. And this is a game changer. You can use this in any project. So this is to learn about SMPS design, again, $14.99. By the end of the internship, you will be finishing with 50 projects, which will be worth of 10,000 rupees. And plus you get the 3 technical recorded courses, plus the WhatsApp group. And not only that, for all of you freshers for first year, second year, third year, whichever case you are, you get 3 individual course certificates. And you can class as your internship, and that will give you to get into the internship role. So with this, if you go to our website, it's 3997, but I'm not going to ask you all of that because you guys are really good and you get all this in a bundle. And today it's 2499, but if you're going to sign up in the next hour, all this comes in, plus the free certificates, plus my own WhatsApp group where you can come and clear all your doubts. And today you are not going to pay. From outside, if you go, it will be 60,000, 70,000 easy, 80,000 for all this. All I am asking today is $14.99 plus 18% GST, which is nothing, as you know. That's very little money. So I would like you to get a very good benefit. So that's why I'm giving you this offer straight away. I'll share you the link. So please do save this link and then put through your funds through. So this will give you 3 technical courses recorded. The C programming worth 10 days plus in the 10 days, you get 1 day and 2 days of projects. Microcontroller programming of STM32, you get 30 days worth of contents plus 2 major projects. That's almost like 30 days, but you get about 45 days worth of videos in there. And then PCB design, it's another 8 to 10 days with A to Z from start to finish. Plus at each and every course, there are separate interview task questions. If you prepare that, you will definitely clear the interview. Those are all possible questions. So if you do want to invest this, imagine you are investing only $14.99 plus 18% GST. But once you get into that industry, immediately you jump into 3 lakhs, 4 lakhs. So that's why I ask you to invest wisely. So if you do put through this and if you purchased, put through in the chat box that you did, so I can let my team know and they will send you the access immediately. But give us 24 hours for you to get access to get all these courses. So what is the difference? As you already know, today's webinar got no clearing, doubt clearing, apart from mini session. You will get a ebook, but with the 3-in-1 bundle, you get 3 course certificates plus all the recordings. All these courses come with a lifetime validity. So for example, if you want to study now for exam, if you want to come back and watch it, the video and the recording is all yours. You will have your own dedicated login. You can go and log in and you can check and you can learn. It will be something like this, which I'll show you as well. Which will be after you purchase, after you put through the subscription, you will be sent login details to your registered email. Through that email, through that login, you can log in and you will come into a portal where it's called Learning Management Portal with A2Digi. It's called gowith.a2digi.com. And if you come in, there is C programming, STM32 30 days, and PCB design. So I would advise you to start with C programming, move into learning STM32, and then move into learning PCB design. So if you click on C program, this is the module you will see. So if you go in, so I have given everything categorized. Day 1, introduction to C. You write your first C program and you learn all the basics. And you go into learning the operators and how the while loops is used and how to write a function and how this number system. Today I talked to you about the number system, which is the basic key for any project. I went in depth and I covered everything in here. And then how the memory and how the microcontroller is used and how the memory is allocated, etc. Plus you get project day 1 and project day 2. So you get to learn about 6 different projects, everything from scratch. You don't have to know anything. You just follow this and you will be an expert. And then at the end of every course, you get at least 100 Q&A, possible interview questions and answers, which will definitely help you to prepare for your interview, and you will be really, really confident to finish and get that job. So once you are finished, then simply go back to your main dashboard, and then you can jump into STM32, and likewise you can learn all this STM32. So introduction to EST, choosing the right components, architecture, IDE, real-time debugging, so you name it. So there are later resources now and there. I included a lot of resources for your help. USART, fault finding, interrupt, system tick timer, task scheduler, ADC, LCD, pulse width modulation, communication protocol. There's a mini project, major project, Bluetooth-based, IoT-based Wi-Fi system, and possible interview questions right at the end. So a lot of students give me feedback every day that they really, really hesitated to buy first, but once they got into now they're all really happy that they made the right choice and go into PCB design and start to learn about this SMPS board, because this is the highly recognized 42 lessons in there. How to download for a start, how you can use the license files, and then the course introduction part 1, start with the new project, learn to create schematic symbol, learn to draw schematic in Altium Designer, how to create footprints, working with the layout and the physical connections, how you can improve your layout, and finishing with the DFM, design for manufacturing availability. And then attach your top layer and bottom layer. Plus, I have given you plenty of bonuses. These bonuses alone, if you search anywhere in the industry, this will be alone 10,000, 15,000, but I'm giving it for free just because you're signing up today with $14.99 plus 18% GST, plus additional bonus of possible questions and the resources for all this complete project. So all this today at this rate, $14.99. So if you sign up in the next hour, you will get that. What is covered in this bundle? You get the fundamentals of embedded C programming, begin with this ARM Cortex-M4. You learn the microcontroller architecture. I covered a big IoT project and design your own PCB board. All these 5 essential for any fresher to get into job. Once you know all these 5, you will pass the interview, you will pass the technical round, and HR round, everything, you will get a job. Okay, I'm just pausing this. I'll come to the chat. I'll see. Uh, Atharva, yes, I have given the link. So if you click on that link, then you will come to the LMS system and you will do the internship for the various electronic fields. So all this combined and I'm giving into one bundle. That's why that link is there. Thank you, Atif. That's very nice of you. Yes, that's unfortunately that happened, the Ahmedabad crash, and I'm sorry that happened. But thank you so much for giving me such a compliment to say it's a great presentation. Thank you. All the hardware that is on top of the course. So if you really want the hardware, I will share you a form. Please do fill this form. So I will get my team to organize to get you the hardwares that you are necessarily wanting. So please fill in this form and send it back to us. As soon as you click submit, it will come to us. So we can take with that. Yes, all the course recordings will be in the after the subscription, all will be shared to you with your own login. So you can go and purchase your login. Yes, Mohammed, I'm going to send it to you right at the end. I got one more thing to cover, and after that, I'll send that ebook to your email, your registered email. So please make that purchase. Don't hesitate. A lot of people were like that. They bought that and they are now really happy with their job. So please do that. Okay. So so with this, you will be able to necessarily build your portfolio by end of all finishing those 3 courses that I have put through in the internship. You would be able to finish 20 plus projects. From that, you can create all the ideas and have at least 30 to 40 different pages. And from there, you can summarize into 2 pages or 3 pages resume. And before attending any interview, do a research about that company and that job role and be active in LinkedIn, because these days people come in LinkedIn and they find people and they do it. What is your resistance for not to buy this course? Is it feeling that I'm having a gap, or no, I can't be accountable, or I don't have any technical skill, or maybe this may be work out or not, or no money, like that? So save this link and purchase it because it will be really helpful for you. And work on yourself. That's how you can break your resistance. Work on yourself. Self-investment is the best investment. So develop abundant mindset. So the more you invest on yourself, the more abundance will come to you. So change your environment. So don't dissociate with negative people. Self-education will bring you a lifelong learner and being a long-time fortune. So please do that. You only need this course, so you can upskill on the way. If you want to make a career switch also, this will also help. In my community, already 2000 plus community members are already benefiting from this one particular internship. And to give you a brief as well, I can go into my site A2DG and I can show you at the moment, if you all want to come into A2DG, they all have to pay that price with 999 1499. So if you go to service and courses, so this is our website. Still loading. So you can see the 999 1499 499 1499. So I'm bundling it all the 3 for you to get that price of 1499. So that's why this is a very good offer. So please make use of it. Okay, returning back to finishing off. So these are all some of my previous students who kind enough to give me a good review of what they thought about, and you can name it. You can go and Google it and you can see it A to G. You will get all this. So all these three in one bundle, you get all these three technical courses, recorded videos worth 4,295, 50 plus project source codes and materials. That alone is 10,000 rupees. If you go to anywhere in Udemy or anywhere, you will be spending at least 25,000 to learn 50 plus projects. And you get a lifetime private community with the WhatsApp group for your own doubt clearance worth about 10,000. Plus, if you are in the second year, third year, you get 3 individual course certificates. So you can complete C program now. After 3 months, you can learn your theory subjects from your university and learn microcontroller. You'll get a separate certificate like that. So lifetime validity for all courses, and all the completion code certificate all comes in free. If you go to our website, if you do all the math right, it will come to 3,997, but today's value 1,499 plus 18% GST. So before we conclude, I would like to give you about a brief overview about the embedded development lifecycle. So this is the total embedded development lifecycle for any project, combined software and hardware. In the industry, there will be separate software team and hardware team, depends upon the size of your company. They'll be doing all sorts of this. Every box that I listed here, separate teams in that particular department. So likewise on the top, these are all software team, and these are all hardware team, and these are all integration team, testing and tuning team, and a deployment team. So at first, both the software and hardware, they will be doing the selection, and then they'll be doing the hardware coverage, and then they'll be checking in the software side the networking protocol. And the board bring up is the PCB layout design that we just learned. That will be the board bring up, and then Java support is to give you the feel about the particular application. Simultaneously, the graphics support will give you the front end and the back end support as well. And then the board diagnostics, this is when the DFM comes in. So all this they will do simultaneously in the industry. And I've been into over this 25 years, I worked in every single department that you can think of. And then simultaneously in the PCB, in the software, they do what is called a real-time operating system simulation. And in the hardware, they do source level debugging. So once all this area is completed, then they move into what they call as an integration and testing and tuning team, where they do rapid prototyping in there. And this is where they do the real-time system analysis and debugging in the hardware side. In the software side, they'll be looking about the real-time data visualization and if there is any memory leakage. Once they're happy with that, then the final stage is to deploy your project. In the software, it's called post-mortem debug, meaning over the air, you can send certain file to update firmwares. That's what the firmware updates is. Sometimes if you're using your Android phone, your Apple phone, there will be a software update. So these post-mortem debug is what that's associated with. So they send you with your profile and you can just go and click and it will be updating for you. In the hardware, you go and sit with your particular company manager and you can do in-field debugging. So all this whole nutshell is the embedded development lifecycle. And this takes, if you really dedicated and if you're in the industry to come across the whole thing, it takes at least 10 plus years to work each and in every department. And I spent the last 25 years to learn each and every step of it. So that's why I am putting it out here in a form of 3 course internship for you all to get that. So please make use of that link. I will share that and please put through that purchase because it's for your own better tomorrow, for your own life. I'll share the payment link. Assist with job references. If you finish, this is for Tejas. Yes, if you finish all the 3 courses and if you finish and if you get the certificate, I'll refer you to all my known contacts in the industry and they would be able to help you with job assistance. I'm not providing any job assistance. My job is to give you that to get to that assistance level, and the other people will help you definitely. Yeah, so if you want to follow me in LinkedIn, I will also share you my LinkedIn. That's my LinkedIn. So please save this payment link. If you do today, you will get that price. If not, if you go to my website, you have to pay that price. And also, please pass this link to your known friends. If anybody of you want to learn about embedded system design and PCB design, please do pass on that the payment link that I shared, and it will be very, very useful for anyone. And once you learn in a group with between you 3 and 4 people, you can form your own team, and you can start to develop your own application, and you can start to earn money because that application will be useful for someone. So while you are studying, also you can earn money. So that's what my intention is. So please make use of that. That 14.99. It's really, really worth buying it. A lot of students done that. So I would like you to do that too, please. Okay, time for any questions if you have any doubts. And thank you for all of you who stayed till the end. Your bonus is coming, the free ebook Electronics for Embedded Designers. It will be sent to your email at the end of this free webinar. You will get it by Monday morning, free ebook. Yeah. If you have any questions, you can ask me in the chat box. Thank you so much, Adarva. If you'd like to give me a review, please go to Google A2DG and you can write a big review. And I hope you all can give me 5-star reviews, please. Thank you, Adarva. If any of you have any other doubts, you can ask me. If not, I sincerely thank you, each and every one of you, for staying this long on your Sunday morning. Thank you so much for your patience, and I wish you to have a lovely break from your screen. If you don't have any other questions, with your permission, if you all saved that payment link, please do so. Check with your parents, with your other friends, other colleagues. I'm sure this is worthwhile spent. Click on that link and put through that purchase. And once you put through, if you have any questions and if you have any further doubts, you can also send me an email to my a2dg.com and I will be able to help you with that. Yes, sure, Adarva. There are more sessions coming. So look through our ads in Facebook, Instagram, in all other social media. So you will be notified. So please do come and attend, and you will get some sessions similar to this. So please go and make sure you click on that purchase because it's for your own benefit. Doesn't matter if you are still in the second year, third year, it will also help you. Because when we were studying, we were not able to have this sort of facilities in the industry back then. Every course that when I purchased, everything was 2 lakhs, 3 lakhs. For example, I paid almost 3.5 lakhs to learn C programming when I started. I spent about 7 lakhs to learn about one microcontroller programming. And for PCB design, I spent 11 lakhs to learn Altium Designer alone. But I don't want to be that person. I want to give you in short bundles. So that's why I put everything, and I want it to be reached to a lot of people. My mission is to hit to at least 100,000 people out there. That is more than 1 lakhs people there, engineers, especially in India. So that's why that pricing. They both are equally best. The answer is for Darwa. Both PCB design and embedded system are equally best. So if you know both, and that's when your pay increases from say 8 LPA to 20 LPA if you have both the skills. Okay. I personally, thank you, Janvi, thank you, Vishan, thank you, Atif, thank you, Siddharth, thank you, Rubala, thank you, Sangeeta, thank you, Swati, thank you, Kartika, thank you, Ayush, thank you, Raghu, thank you, Abdul, thank you, Adarva, Thank you, Radhika. Thank you, Kodishwara. Thank you, Tejas. Thank you, Varshita. If you have any other questions, I will leave the chat for the next couple of minutes. If you don't have anything, with your permission, type P. I can close and you can go and enjoy your Sunday afternoon. But please save that link, and you can also purchase later on. Please, because the link will be valid for today. So go and talk to your parents or any other friends, colleagues. Come back and make use of this nice offer. That's the link. Okay, Ayush is asking how to get in the industry. Again, I'm saying if you study these three courses, you will know all the fundamentals. You will cover all the, you would, by the end, you will come to know about 450 different possible interview questions. So once you know that, go to job sites like Naukri, and there are other job sites. Look for the job ads. Most of the companies will leave their company name and there will be some link. Ring or send an email to that particular company. Tell them that you completed an embedded course or a PCB design course and you know this tool and you know this project. If there is any opening, please let me know. And when you approach to them, they will definitely ask you to come and chat with them and they will offer you the job. This happened in the previous batch. So yeah, that will also help you. I'm getting issue with payment. It's done. Link stuck. Is there any option? That link will give you to use other payments. Like I don't know what payment system in India they use, but I heard there is internet banking as well. You can click on that link and you can purchase through internet, and there are other payment options. Yes, sure. I will share this in the WhatsApp, Kotishwara. So the others can also buy, and I'll open the WhatsApp messages. So you can also send your messages, and you can also tell to others who failed to attend due to various reasons. You can tell them how beneficial to you, so they can also purchase the course. So one sec, I'll just open the chat on that. So you can send messages. Okay, so please go and tell your other friends in the group to uh, come and purchase this course because it will be really helpful for them. And also, if you'd like to leave me a good review in the website, go to a2dg.com and please write me a good review. And I hope you can give me a 5-star review, please. Thank you. Thank you. Okay. In the next session, I may talk to all of you about resume. So maybe I can tell you a trick here and there, so you can get your resume shortlisted. So I'm planning for a new course, which is very soon. I'll let you know. Okay, Atif, can you send me an email? I will ask my team to forward you a different link. I'm not sure of what link for other countries. So certificate is at the end of every course. C programming, once you finish, you'll get a separate certificate. At the end of STM32, you'll get the second certificate. At the end of PCB design course, you'll get third certificate. So you get 3 individual certificates, and that worth a lot otherwise. So yeah, don't hesitate to buy this course. Okay, could you send me an email to that enq at a2dg Atif? Because that email will be seen by my team, so someone will be answering you very soon. Because I'm not in the other. Okay. Okay, I'll share the link again here, the payment link. So make use of this link. I will also post that into our I'll also post it there. So please to make use of that link, and please do purchase the course. It is for your own benefit, so you won't miss out on this. I'm just attaching the. Just give me one moment. I'm just attaching the payment link into the other groups. So just give me copy. Um, Okay, I have shared the payment link in the group as well, the June 15th 3-in-1 group. So you can also use that link to make through your purchase. So yeah, so please make use of that. And with your permission, if you don't have any other questions, could you type P in the chat box so I can close the session? Yeah, okay, Tejas. You can buy the 3 courses. You can use the PCB design later on. So why pay extra $14.99 for PCB separately? So it comes in that total package. You get all the 3 courses for that price. So get all the 3. That's my humble suggestion. Once you finish C programming and STM32, you can then move to learning PCB design. It's very easy. It's not hard. This is for Tejas. So if you are in the group, so please do send some comments in the group to say how the session was. And if you don't have any other questions, so could you type P in the chat box so I can close the session, and I would be able to see you in a different session. Thank you so much, Kotiswara. That means a lot to me. Also share that comment in the WhatsApp group as well, so the others will know. Thank you, Bua. Yes, thank you. Thank you so much for staying back all this time. Okay, I guess the others are all busy. So the ones who are active here, could you type P for your permission so I can close the chat? And I'll see you in the next session. So please go and enjoy that lovely break. And I'll see you shortly in another session. This is Arul Anbukarasu. I'm signing off on behalf of A2DG. Huru for now. I'll catch you at another session. So I'm going to close the session. So please do save that payment link and put through your purchase. I'll share the link again here. So please make use of that. I will leave the link for a couple of minutes so you can save it. And I'll wait here in case if you have more questions, I can answer your questions. So please type in the chat box if you have any other question. If not, I can type P so I can end the session. Just waiting for any chat. If you have any other question, you can type here in the chat box. Excuse me. Okay, I take it that you are all either busy or have other things to do. Okay, I thank each and every one of you for attending this session. So please go and enjoy your dessert break from the screen, and I'll see you in another session. So this is Arul and Bukarasu. I'm signing off on behalf of A2DG. I'll see you in another session. I'm closing down now.